Our session today in quantitative methods will be on linear regression. Linear regression. So linear regression is a statistical method that we use to predict values of one variable from the other, where we are measuring what is called causal relationship. So we are going to learn how to come up with the linear regression equation. It's also a topic in form under forecasting. So we are going to look at linear regression and how to come up with the dependent and independent variables, as well as the correlations and correlation coefficient. So when you're dealing with linear relationships, we must understand that there are two types of relationships that we're going to look at. In fact, three. There is a positive relationship and a negative relationship. So I'll try to be as basic as I can. So when you're dealing with the regression equation, the variables we are going to be concerned more about will be the y and the x, whose relationship we'll be studying. So we'll give them names. The x is what is called the independent or the predictor or the explanatory variable. The y is what we call the dependent or the outcome or the response variable. So when you're doing an x or y plane, it is convenient that you understand how these look like. So the dependent variable is a y, the independent variable is a x. So when you're drawing the linear regression equation, the linear regression equation is given by y is equal to a as bx, where a is a cutting point, the intercept here, and b is a gradient, the slope here. So other versions will give you the regression equations as BO plus B1 and X. So BO is same as the y-intercept, and B1 is what we call the gradient. So this is the same as the A, and this is the same as the B. So when you're dealing with writing an equation, so the slope simply measures how much of one increment in y is accompanied by the increase or decrease in x. So linear regression is very important for multiple reasons. It is there to measure the relationships that exist. So if you have a positive relationship, it looks like this. So meaning our R is positive. R means coefficient of correlation. So this is a positive relationship. And again, if the dots are close to each other, it means our R squared is greater than 50, is strong. So the relationships can be in three ways, like I said. You can have a positive relationship, which is strong. You can have a positive relationship, which is weak when the dots are apart from each other. You can also have a negative relationship, which has an inverse relationship like this. So y is equal to a minus bx. So when the relationship is negative, the gradient is also negative, but this could be a negative yet strong relationship, a negative yet weak relationship. So what measures the type of relationship is the coefficient of correlation. So the same coefficient of correlation, when we square the same answer, the name changes to coefficient of determination. It determines how much of x is determined by the variation in y. So this is how the relationships look like. Now, I've talked about the functions of the regression equation to say, number one, the regression equation is there to tell us the type of relationship that we have, whether it's positive or negative. It is also there to ascertain the prediction, to predict whether we have a positive relationship or we have a negative relationship. Then I've also talked about R, which stands for the coefficient of correlation. So if you have R 0.735 here, it simply tells you that this is a positive relationship because of the positive answer that we have. And we have R squared already. After this, we square it, it's giving us 0.540. So this means 54% of X is as a result of Y. So this is the predictor. It gives you the strength of the relationship. So R, it measures the strength of the relationship, the linear response. R squared, it measures how much of the variation in X is measured by Y. So R squared is a proportion of the variation in response to the explained model. So this is more important for your research because much of what you're learning in quantitative methods will equip you to look at all causal researches. So let's go back to figures now. So I'll give you an example of some figures we're going to use to calculate the linear regression equation. So if you're given the values of X as 1, 2, 3, 4, and 5, and the values of Y as 1, 1, 2, 2, and 4. So we can sketch this X or Y plane. So here we have our X. So our Y is here, our X is there. We have 0. On the X's, we have 1, 2, 3, 4, and 5. The Y, we have 1, 2, 3, and 4. So let's plot these appropriately. So first one is 1, 1, put here, 2, 1, put here, 3, 2, put here, 4, 2, put here, and 5, 4, you put it here. So we've sketched. What can we tell about this? What kind of relationship is there just physically by looking? The positive relationship, which is strong. Then we can fill up the table to find the other values that are important. The X squared, the Y squared. So X, Y, we are multiplying this by that is 1. This by that is 2. This by that is 6. This by that is 8. This by that is 20. And X squared here we have 1, 4, 9, 16, and 25. And Y squared, we're squaring this, just multiplying. 1 times 1 is 1. 1 times 1 is 1. 2 times 2 is 4. Again, 2 times 2 is 4. Then 4 times 4 is 16. And so now get to add up these values here. Right, so what is the total here on the value of X? Please participate. So when you total up here, we're going to get what? 5, 10, 15. So this is summation of X, which is 15. And here we add up 8 and 10. Summation of y is 10. We put EY, E stands for summation. And here you top up, what we get? That's 7. Summation of xy is what? 37. And here we top up, summation of x squared, what we get? 55. And here we top up, summation of y squared, what we get? 26. So we're topping up in each of these ones here. All right, so we're told that the regression equation is given by y is equal to a plus bx. A is the y-intercept and b is the gradient. So we want to calculate the equation of the regression equation. So I will calculate the gradient b. The formula for the gradient b is equal to summation of what? X, y minus summation of x times summation of y over n summation of x squared minus summation of x to the power 2. So help me, what is our n? N is the number of pairs that we have. 1, 2, 3, 4, 5. So our n is 5. Number of rows. So what is summation of x, y? So where there's n, we put 5. What is summation of x, y from the table?
N.
X, y is what? 37. Then what is summation of x? And what is summation of y? You can see from the table. Summation of x and what is summation of y? Summation of x is the total of x. So what is the total in the x column? 15. So you put your 15. What is the sum of y? 10. Then you go down n is 5. Summation of x squared, so x squared, don't square this, it's already squared. It's 55. Then here, summation of x to the power 2. So summation of x is what? 15, then you square it. If you compute that, you're going to get our b as 0.7. So you put the 0.7 on the b, you leave the x and the y in the equation. Are we clear so far? Are we clear so far? Any questions? Okay, so we substitute. Okay, so the summation of the A is given by summation of y over n, B summation of x over n. What is summation of y?
That's 10. 10.
So we've got 10 over 5. Then what is the B? We just found the 0.7.
0.7.
What is summation of x?
That's
Summation
15.
of x, 15 over our n is what? 5.
5.
Okay, good. So here we're going to have what? 2 minus 0.7 times what? Times 3. So here we're going to have negative 0.1. So A is 0.1. So just replace it here. And the equation is done. So this is part 1. Find the regression equation or prediction equation. Part 2, you predict if x is equal to 10, what is y? So here that we have the equation, just substitute. So y is equal to negative 0.1 plus 0.7 x. X is what? 10. We put a 10 there. So we're going to have 6.9. Okay, so now let's look at the R. R stands for coefficient of correlation. It shows you whether there is a positive relationship or there is a negative relationship. So it's similar, quite similar to
Hello,
the.
sir.
Yes, please.
Yes, this y is equal to negative 0.1 plus 0.7. Why have you put x10? Because if I see there,
We've been
it
given
is saying
here
15. Or
that
it been,
x is
oh,
equal
I
to
see. Okay.
10. Yeah.
Okay, thank you. Yeah, all right, got it.
Okay. So it may be sometimes maybe 100, maybe any figure. Okay. So here now, this is the longest formula that we. So n x squared. Minus summation of x to the power 2 times n y squared times summation of y to the power 2. So when you substitute, what we're going to have, it's almost the same of what we're substituting here. Your answer will be 0.903. So So this means there's a positive relationship as has been shown here. Then part D, they will ask you to find what is R squared. R squared is you just square that answer there. We're going to find 0.816. What does this mean? 81.6% of y is because of x. That's interpretation. 81.6% of y is because of x. That's in layman's language. Okay. Any questions so far? So this is how